Imagine this. You wake up tomorrow, check your phone, and see a headline so shocking that your mind struggles to process it. Quantum computers have cracked encryption. The internet as we know it is no longer secure. Governments are in emergency meetings. Banks are scrambling to protect financial data. Military agencies are on high alert. Every password, every transaction, every confidential file ever stored digitally, exposed in an instant. Panic spreads as experts warn that our entire digital infrastructure, emails, medical records, state secrets, could now be at risk. It sounds like the plot of a sci-fi thriller, but what if I told you this future might be closer than you? Think, quantum computing just took a massive leap forward, and the implications are staggering. For decades, scientists have been chasing a dream, a new kind of computer that doesn't just process information in the traditional binary system of ones and zeros, but instead harnesses the strange, counterintuitive properties of quantum mechanics. This isn't just about making computers faster. It's about rewriting the very rules of computation itself. To understand why this breakthrough is so significant, let's take a step back and look at how classical computers work. Everything, your smartphone, laptop, or even the world's most advanced supercomputer, boils down to manipulating bits, tiny electrical signals that represent either a 1 or a 0. The more bits a computer has, the more calculations it can perform. But even the most powerful classical computer has a fundamental limitation. It must process information sequentially or in parallel with limited pathways. Imagine a complex maze. A classical computer navigates it by testing one path at a time, step by step, eliminating dead ends until it finds the solution. But a quantum computer, it's an entirely different beast. Instead of using bits, it operates with qubits, quantum, bits that can exist in a superposition of states, meaning they can be both 1 and 0 at the same time. This allows quantum computers to explore all possible solutions to a problem simultaneously. Going back to our maze analogy, instead of testing one route after another, a quantum computer explores all paths at once. It doesn't just solve problems, it transforms the way we think about solving them. This sounds like magic, but there's a reason why quantum computers have remained largely theoretical for so long. Qubits are incredibly delicate. They are prone to interference from their environment. Any tiny fluctuation in temperature, electromagnetic radiation, or even a stray cosmic ray can disrupt their fragile quantum state. This phenomenon, known as quantum decoherence, has been one of the biggest obstacles in quantum computing. For years, scientists have been racing to overcome these limitations, but progress has been slow. Early quantum computers could only maintain stable qubits for microseconds, far too short a time to be useful. Even Google's famous 2019 experiment, where their Sycamore processor performed a calculation in 200 seconds that would take a classical supercomputer 10,000 years, wasn't enough to break through the noise and instability that plagued the field. Until now, a groundbreaking discovery has just changed the game. Scientists have managed to stabilize qubits for far longer than ever before, making it possible to run complex calculations without the system collapsing into chaos. This breakthrough isn't just another incremental step, it's a paradigm shift, one that could accelerate the arrival of quantum supremacy, the moment when quantum computers surpass classical ones in practical applications. To put this in perspective, imagine trying to build a skyscraper out of playing cards. Every time you add another level, the structure becomes more fragile. Now imagine someone discovers a way to make those cards magnetically lock in place. Suddenly, you're not just stacking cards anymore, you're building the future. And here's why this matters. Once quantum computers become stable and scalable, they could revolutionize everything from medicine to artificial intelligence to national security. They could design life-saving drugs in minutes, break even the most advanced encryption, and unlock new frontiers in materials science, energy, and finance. And if that sounds exciting, take a moment to be part of something bigger. Every great journey starts with a few brave explorers. Right now, Cosmic Whispers is just beginning, and your support means everything. If you enjoy unraveling the mysteries of the universe, hit subscribe. It's free, and it helps us grow this community together. So, what exactly is this breakthrough? What did scientists do that no one else could? And more importantly, what happens next? To answer that, we need to take a deep dive into how quantum computers actually work and why they've been so difficult to build until now. To truly appreciate the magnitude of this breakthrough, we need to understand what makes quantum computing so different and why it's been so incredibly difficult to achieve. Picture this. You walk into the largest library in the world, an endless labyrinth of books stretching as far as the eye can see. Somewhere in this massive collection is the one book that holds the answer to your most urgent question. A classical computer, even the fastest supercomputer, would search through these books one by one, following a systematic approach. It might use clever tricks to narrow the search, but at the end of the day, it's still a process of elimination. Now imagine a quantum computer in the same scenario. It doesn't just search one book at a time. It reads the entire library at once. That's the difference we're talking about. This incredible power comes from superposition, a fundamental principle of quantum mechanics. Unlike classical bits, which must be either 0 or 1, a qubit can exist in a superposition of both states at the same time. This means that a quantum computer doesn't just explore one possibility at a time, it processes all possibilities simultaneously. The more qubits we have, the more exponentially powerful the system becomes. But superposition is just the beginning. There's another quantum phenomenon at play, one that Albert Einstein himself called spooky action at a distance. It's known as quantum entanglement. When two qubits become entangled, their states become intrinsically linked, no matter how far apart they are. Change one and the other instantly responds, even if they're on opposite sides of the universe. This bizarre effect allows quantum computers to perform calculations in a way that defies our classical intuition. With superposition and entanglement, a quantum processor could theoretically perform certain calculations in seconds that would take a classical computer longer than the age of the universe. But if quantum computers are so powerful in theory, why haven't we been able to fully unleash them in reality? The answer lies in coherence, or more specifically, the lack of it. Quantum states are incredibly fragile. The slightest disturbance, heat, electromagnetic interference, even a stray vibration, can cause qubits to collapse from their quantum state into a classical one, a phenomenon called decoherence. This collapse erases all quantum computational advantages, reducing a quantum computer to an ordinary, inefficient classical system. For decades, this has been the greatest hurdle in quantum computing. Scientists have developed elaborate methods to counteract decoherence, such as cryogenic cooling systems that keep qubits near absolute zero, a mind-numbing minus 459 degrees Fahrenheit, to minimize atomic vibrations. Others have experimented with superconducting materials and exotic particle states to stabilize quantum information. But no matter how sophisticated these techniques were, quantum states would inevitably decay too quickly, limiting the complexity of computations. Until now, a revolutionary breakthrough has just changed everything. Scientists have found a way to dramatically extend qubit coherence times, allowing quantum computations to last far longer than ever before. This isn't just a minor improvement, it's the kind of leap that transforms theory into reality. Think of it like this. Imagine trying to take a long-exposure photograph at night. Every small vibration of the camera results in a blurry, distorted image. Now, imagine you suddenly gain access to a tripod so stable that you can take crystal-clear photos even over long exposures. That's what this breakthrough is like for quantum computing. It stabilizes the quantum system long enough to perform meaningful, complex calculations. And here's where things get even more exciting. With longer coherence times, quantum processors can begin tackling real-world problems that were previously impossible to compute. We're not just talking about theoretical models anymore. This could mean rapid advancements in drug discovery, materials science, cryptography, and artificial intelligence. Consider pharmaceuticals. Developing a new drug involves simulating how molecules interact at an atomic level, something so complex that even the most advanced supercomputers struggle with it. Quantum computers, with their ability to process countless molecular configurations simultaneously, could design life-saving drugs in days instead of years, or take cybersecurity. Right now, almost all of the world's encryption relies on the difficulty of factoring large prime numbers, a problem so computationally hard that even the best classical computers would need millions of years to break. But a sufficiently advanced quantum computer? It could crack these encryptions in minutes. This is why governments and tech companies around the world are racing to develop quantum-resistant cryptography before quantum computers become powerful enough to break today's security protocols. But here's the big question. If we finally overcome one of the biggest obstacles in quantum computing, how long before this technology becomes mainstream? Are we on the verge of a quantum revolution, or is there still another mountain left to climb? To answer that, we need to look at what comes next, the engineering challenges, the ethical dilemmas, and the potential impact on industries and global security. Because while this breakthrough is a massive leap forward, what happens after this could be even more shocking. The breakthrough we just discussed has shattered one of the biggest barriers in quantum computing, stabilizing qubits long enough to perform meaningful calculations. But before we imagine a world where quantum computers solve humanity's biggest problems overnight, there's something we need to address. What happens next? Because make no mistake, this isn't just an exciting scientific milestone. This changes everything. And as history has shown us, whenever a new technology reaches the tipping point between theory and application, the consequences are often unpredictable. Let's go back in time for a moment. It's the 1940s, and classical computers are in their infancy. They're massive machines, taking up entire rooms, consuming enormous amounts of power, and requiring entire teams just to operate. In those early days, most people believed these computers would be nothing more than specialized tools for scientists and mathematicians, useful but limited in their impact on everyday life. Fast forward to today, and nearly every aspect of our existence, our communication, our economy, our personal lives, revolves around computing power. What started as a niche invention became the foundation of modern civilization. Now we're standing at the edge of a similar revolution. Quantum computing is where classical computing was in the 1940s. But here's the difference. This time, we know what's coming. We know that if we push forward, the world will be transformed. The question is, are we ready for what happens next? To understand the road ahead, we need to break this down into three key areas: engineering challenges, industry disruption, and global security risks. The engineering mountain left to climb, yes. Stabilizing qubits is a massive step forward, but it's not the only challenge standing between us and practical large-scale quantum computers. One of the biggest remaining obstacles: scaling. Today's most advanced quantum processors contain only a few hundred qubits at most. To unlock their full potential, we need millions, and each additional qubit introduces new complexities. Maintaining coherence across a handful of qubits is one thing, but ensuring that an entire quantum system remains stable as it grows in size. That's an entirely different level of difficulty. Think of it like building a symphony orchestra. A small ensemble might be easy to coordinate, but as you add more musicians, the challenge of keeping them in perfect harmony becomes exponentially harder. One out-of-sync instrument can throw off the entire performance. In the quantum world, even the slightest interference can introduce catastrophic errors. This is where quantum error correction comes in. In classical computing, if a bit flips from 0 to 1 due to an error, redundancy and error-checking algorithms can easily correct it. But in quantum computing, the delicate nature of qubits means that detecting and correcting errors without destroying quantum information is extremely difficult. Scientists are making progress, but true large-scale quantum error correction is still a work in progress. So, when will we see a quantum computer with millions of qubits capable of revolutionizing industries? Some estimates suggest within the next decade, but as we've seen with technological breakthroughs before, when progress reaches a certain momentum, things tend to accelerate faster than expected. Industry disruption. Winners and losers when no axi, quantum computing reaches maturity. It won't just be a scientific curiosity, it will completely disrupt entire industries overnight. Let's start with pharmaceuticals. As we mentioned earlier, quantum computers can simulate molecular interactions with unimaginable speed. This means that the time and cost required to develop new drugs could plummet. Diseases that were once considered incurable could see groundbreaking new treatments. But here's the flip side. Traditional pharmaceutical companies that rely on years of trial and error research could struggle to adapt. Then there's finance. Quantum algorithms could optimize financial models, identify hidden market patterns, and execute trades with precision that makes today's high-frequency trading look primitive. The companies that embrace quantum computing will dominate the financial world, but those that don't, they could be left behind in a rapidly changing economic landscape. And then we come to artificial intelligence. Right now, AI is limited by the constraints of classical computing. Training deep learning models takes immense computational power and energy, but with quantum computing, AI could train exponentially faster, leading to advancements we can't even predict. This could mean AI systems that understand and respond like never before, or even the emergence of true artificial general intelligence. The bottom line? Quantum. Computing isn't just about making things faster, it's about making things possible that were previously impossible. And that brings us to the final and perhaps most concerning point. 3. The global security arms race. If you think the world's most powerful nations aren't watching quantum progress with laser focus, think again. The moment quantum computers reach the point where they can break classical encryption, the entire foundation of cybersecurity collapses. Every encrypted message, every financial transaction, every military secret stored digitally. Vulnerable governments are already scrambling to prepare for what experts call Q-Day, the day when quantum computers become powerful enough to render today's encryption obsolete. The US, China, the EU, and major tech companies are all investing billions in quantum-safe cryptography, trying to create new encryption methods that can withstand quantum attacks before it's too late. But here's where things get really interesting. If one country reaches true quantum supremacy before the rest, it could tilt the global balance of power in ways we've never seen before. It would be the ultimate intelligence advantage, allowing one nation to decode the encrypted communications of every other nation on the planet. It's no wonder that some experts say the race for quantum computing is the new space race. Except this time, the stakes are far higher, and it's not just governments. Hackers, cybercriminals, and rogue states are also watching closely. Even if quantum computers aren't powerful enough to break encryption today, sensitive data stolen now could be decrypted in the future when the technology matures. This is why cybersecurity experts warn that organizations need to start transitioning to quantum-resistant encryption now, before it's too late. So, where does this leave us? We stand at a crossroads. We've just overcome one of the biggest obstacles in quantum computing, and now we must decide how we wield this power. Will it be used to unlock scientific discoveries, cure diseases, and advance humanity? Or will it trigger a new era of cyber warfare, economic upheaval, and digital vulnerability? One thing is certain, what happens next will change the world. But, and there's still one final piece to this story. What should we expect in the next 5 to 10 years? How close are we to true quantum supremacy? And what can you do to prepare for the coming quantum age? We are no longer asking if quantum computing will change the world. That question has already been answered. The real question now is, how soon will it happen? And are we ready? If we take everything we've discussed, the engineering breakthroughs, the industry disruptions, the global security implications, it all leads to one inevitable reality. The quantum age is approaching, faster than we ever expected. And while some believe we have decades to prepare, the truth is far more urgent. The next 5 to 10 years, a ticking clock. Many experts once predicted that practical quantum computing was at least 30 to 50 years away. But with recent breakthroughs, that timeline has collapsed. Companies like Google, IBM, and Microsoft, along with quantum startups, are making progress at an accelerating pace. Here's what's coming in the next decade. Within the next 5 years, we will see quantum computers surpass classical systems in specific real-world applications. This won't be general-purpose quantum computing yet, but industries like pharmaceuticals, materials science, and optimization problems will begin actively using quantum algorithms for real breakthroughs. Within the next 10 years, we could reach a point where quantum computers achieve what's known as fault-tolerant quantum computation. This means error-corrected, stable quantum systems capable of sustaining computations long enough to handle practical, large-scale problems. At this stage, the cybersecurity threat becomes real. Governments and corporations will need to have quantum-safe encryption fully in place before Q-Day arrives. Beyond 10 years? That's when things get truly unpredictable. If quantum systems scale is expected, we could witness the rise of artificial intelligence models powered by quantum computing, AI that learns, evolves, and solves problems at a speed we can barely comprehend today. Quantum AI could unlock scientific discoveries that redefine our understanding of the universe itself. But the real wildcard isn't just in the technology, it's in how society, governments, and industries react. Because with every new technological leap, history has shown us one undeniable truth. Those who adapt thrive, and those who resist get left behind. Are we ready for the quantum future? Let's pause for a moment. Take a step back and imagine you're living in the year 1995. The Internet exists, but very few people understand what it will become. Most companies don't take it seriously. Governments barely regulate it. People don't realize that in just 20 years, it will become the backbone of global civilization. Now look at 2025 and beyond. Quantum computing is in the same place. That classical computing was in 1995. Right now, most people don't see it coming. But those who do, the ones paying attention, have the opportunity to prepare for a future that will redefine everything. What can you do to prepare? You don't need to be a quantum physicist to stay ahead of the curve, but understanding this technology and its impact is crucial. Here's how you can prepare for the quantum revolution. Stay informed. Quantum computing isn't just for scientists anymore. As it moves into real-world applications, understanding its implications will be as essential as understanding the Internet or artificial intelligence. Learn about quantum-safe encryption. If you work in tech, finance, or cybersecurity, now is the time to start looking into post-quantum cryptography. Companies and governments are already preparing for Q-Day. Those who don't will regret it. Look for investment and career opportunities. Just as the rise of the Internet created new industries, the quantum era will do the same. Whether you're in science, business, AI, or security, quantum computing will open doors that don't exist yet. The smartest minds today are already positioning themselves for the next wave of innovation. The final question: what happens next? Every time humanity takes a technological leap forward, we face a choice. How will we use this power? The breakthroughs happening right now will shape the future, not just for technology, but for society, economies, and global stability. Quantum computing has the potential to solve our greatest problems, from climate change to disease to artificial intelligence. But in the wrong hands, it could also create new vulnerabilities and risks we've never faced before. The most important thing? We can't afford to ignore it, and that's where you come in. What do you think? Are we ready for the quantum revolution? Do the benefits outweigh the risks? Or are we rushing into something we don't fully understand? Let's discuss it in the comments below. Your thoughts might just be the key to understanding what's coming next. And if you found this video fascinating, share it with someone who needs to know about quantum computing before it's too late. Hit the like button to support our work, and let's keep unraveling the mysteries of the universe together. The future is coming faster than we ever imagined. The only question is, are we ready?